Good morning, good afternoon, good evening, everybody, and welcome to INE's Obtaining Your CCIE Routing and Switching certification before the program changes begin. My name is Brian McGann. You may have seen me from such videos as CCIE Routing and Switching, Security, Service Provider, Data Center, CCDE. You can see my email address there, bmcgann@ine.com. Feel free to send me any questions that you have after class. Follow me on Twitter at Brian McGann. Follow me on linkedin.com/in/bmcgann. This class is a little bit different format than normal. We're using the GoToMeeting format, so you guys will only be able to hear my audio. You won't, unfortunately, be able to see my beautiful face today. My camera's not working. So you can see a picture of me there. Just imagine in your mind that it's me, Brian, talking about these topics today. So what are we talking about today here is mainly going to be three major points. First and foremost, what are the new changes that they're adding to the CCIE routing and switching track? Second, when do the changes go into effect? Okay, so in this case, we're mainly talking about how do we pass the exam now? Okay, we don't want to wait to these new changes because there's a lot of new technologies that most people haven't yet had a lot of practical experience with deploying. Okay, and then last before least, we'll look at what the timeline is to talk about do you realistically have time in order to pass CCIE routing and switching before that. Okay, before that meaning these important dates that we have here, which are going to be February 23rd in 2020. This is going to be the last day that you could take either the CCIE routing and switching written exam, which technically you could take this and then qualify for the next lab exam. But I'm not really 100% sure why you would be waiting to Feb 23 to take the written. Ideally, take the written today, take it tomorrow, take it sometime this week if you have not taken it and you're trying to get a lab date before the actual changes go into effect. So this is really going to be our key date. Any lab exam that you schedule before February 23rd, 2020, that's going to be the current format, which is CCIE routing and switching version 5. Once we go beyond that, February 24th and beyond, this is now where we have that change in the written exams, where this written exam Encore 300-401, this is going to qualify you for CCNP Enterprise Infrastructure, which basically is going to be CCNP routing and switching, but it also qualifies you for taking the new routing and switching lab exam, which they're now calling CCIE Enterprise Infrastructure. So for those of you that already have CCIE R&S, the name is just going to change. Once it goes past that point, I believe just your old routing and switching certification is going to be listed as Enterprise Infrastructure. But the key point here is that there's two different sub-certifications. There's Enterprise Infrastructure and there's Enterprise Wireless. So the wireless exam got rebranded CCIE Enterprise Wireless. Routing and switching exam got rebranded CCIE Enterprise Infrastructure. The important point about this, though, is that for either of these that you go to attempt, the written exam is the same, which is that Encore 300-401 exam number. Okay, so what is our particular time frame? It gives us about 8 months. Okay, typically changes are announced about 6 months in advance. So they're technically doing us a favor here by giving us two additional months for preparation. But I was checking the schedule recently because I myself had just passed the routing and switching written exam, the 400-101. I passed this at Cisco Live in order to recert my certifications. So I'm able to log into the scheduler and at least see what dates are available, like do they have any off dates, do they have any on dates ideally, and the schedule is still pretty wide open. Okay, so next let's talk about what are those particular changes. So what are the changes we're trying to avoid here, right? So it's essentially the current routing and switching version 5 blueprint, plus we're adding 3 main new topic areas: software-defined access, or SDA, software-defined WAN, or SD-WAN, and then automation. Now, the first 2 of these, SDA and SD-WAN, they both fall under the software-defined infrastructure for the new blueprint. So the 2 of these together is going to be about 1/4 of the exam. Now, at this point, we're not really going to get into tons of details about what are these changes specifically and how do the technologies work. because we're going to have a number of sessions on this later. Specifically, what do they mean by Cisco DNA Center, or what do they mean by building the underlay versus the overlay? But in general, the way that this works is that Cisco DNA Center, this guy is the controller. Okay, you could think of this in the data center like the APIC. Okay, APIC is the one that makes all the decisions for the Nexus fabric, for the Nexus 9K switches. Okay, so DNA Center is going to be a GUI that's a controller, and what it does is that it logs into the routers and it builds the underlay network. So specifically, we use ISIS routing in order to get reachability between the different switches. Okay, we basically have a layer 3 fabric for the connectivity down to the access layer, and then we also have the overlay fabric design. This is where we have the actual application data, and what this allows us to do is to build a layer 3 fabric, but then based on how we choose what devices are able to talk to what devices, we can either do this with layer 3 routing, or we could do this with layer 2 bridging. So the idea being is that if our network looks like this, that we have the core, and then we have access switch 1, and we have access switch 2, and we're running routing between the two of them. Okay, if we were running routing, normally what we would not be able to do would be to take host A and host B and put them in the same subnet and bridge traffic back and forth between the two. Now, in the case of SDA, or software-defined access, we have a tunnel that goes between the switches. Okay, specifically, it is a Lisp and a VXLAN tunnel. Okay, they're pretty much the same in terms of encapsulation, but the host A can use this tunnel to reach host B from a layer 2 switching point of view, not just from a layer 3 routing point of view. Now, unfortunately, though, the big shortcoming of preparing for this is going to be the Cisco DNA Center itself, which runs as an appliance on a UCS box, and then the underlying Catalyst 9000 switches, excuse me, not Nexus 9000, Catalyst 9000 switches that the DNA Center is actually doing the programming towards. Okay, so like I mentioned, we're going to come back to this in much more detail later once we start to do the updates for the exam. Okay, second portion of this is SD-WAN. Okay, so SD-WAN is going to be more of a virtual solution, so you can see vEdge, vSmart, vManage, vMon. So this is not going to be as big of a deal in order to replicate this from a lab point of view, because as far as I know, everything that they have in the solution can be currently virtualized, but we'll have to wait and see once we get a little bit further digging into this. But from a kind of high-level overview, essentially what SD-WAN is going to allow you to do is that you have your router edge, and then you have multiple circuits. Okay, let's say that we have an MPLS private circuit, and then we have just a cable modem, okay, like DOCSIS 3. Okay, the problem with this originally is that when you're doing equal cost routing, we would be distributing the packets on a one-to-one basis. So there's really no intelligence from the router when it goes to send those packets out, which direction would we want to send them, and it has no view as to the statistics of the link. Like, do we have low latency? Is the current link dropping packets? Something like that. Okay, this is effectively what Cisco SD-WAN, or just SD-WAN in general, is trying to do for us. So with the SD-WAN controller and the software, it's going to allow us to group these WAN links together, and we'll say, well, maybe for every 9 packets I'm sending this way, I'll send 3 packets this way, depending on the current conditions of the network. Then down the road, if something changes, I can modify my ratio as I'm forwarding between these two interfaces. Okay, so together, both of those are going to make up 25% of the new lab exam, which is both called software-defined infrastructure. So again, for the first section, this is, wrong way. So this is SDA, for software-defined access. And then the next portion is SD-WAN for software-defined WAN. Okay, last but not least, we now have automation. So automation is making it into all of the tracks now. So unfortunately, those of you like myself that had set programming down about 20 years ago and hope to never pick it up again, we're going to have to do that now. Okay, so we'll need to know, how do we interact with the vManage API? Okay, what was the vManage API? This was under our software-defined WAN. This is the management plane. Okay, so basically what this is saying is that if we want to configure SD-WAN, I want to do it programmatically. I want to do it programmatically with either Python, or I want to do it with Google Postman, which is the GUI way of creating these API calls and then building them into kind of run books of scripts. Also, we have interaction with Cisco DNA Center. DNA Center is going to be for the software-defined access, not the software-defined WAN. Then 5.3c, it says interaction with the Cisco iOS XE API. Okay, so we're going to be programming the regular routers. So using Python, okay, either using Python or using Postman. So basically going forward, I don't think we have an option, guys. We're going to have to go into programming, assuming that we want to stay relevant in this type of environment today. Okay, so let's get back to, can we actually skip over these changes and get to our CCIE routing and switching attempt before that? Okay, so can you obtain it? Yes, you can. And luckily, lab dates are still wide open. But I would highly, highly recommend that you schedule early and potentially often, because, you know, I hate to say that you need to go to the routing and switching exam just as kind of a fact-finding mission, but unfortunately, it is fairly far and few between that you pass on your first attempt. Okay, so make sure you look at your local center. For the United States, that's now Richardson, Texas. For Europe, typically that's Brussels. So right now in Richardson, there's only dates available in July and August. If you go beyond that, it shows the schedule as red. And I think that just means that you're not allowed to book any dates out beyond 90 days. So let me go ahead and actually open this up, and we'll see live. We'll see live what is the actual schedule. But I need to not show you my scores for the written exams, right? Okay, so let's log in. And then exam scheduler. Okay, so let's say we want Richardson, Texas. We want routing and switching for Richardson. So we have a couple dates in July, sparse ones in August. September has a couple weeks. And then beyond that, it goes to these red dates. So I'm hoping, because today is the 18th of June, I'm hoping that this is just the 90-day counter. So June to July is 1, 2, 3. Yeah, so I believe that you're just not allowed to book these dates out. So just another reason that you should book early and potentially often. So what are the other major ones? Typically just Brussels and Richardson. Brussels looks like it's a little bit further open than Richardson is as well. Okay, so in June, there's still seats. So if you want to go jump on a plane right now, go fly to Belgium. Okay, that's an option. I actually have had candidates do that in the past, go from one time zone to a very, very far time zone away, just because these dates were not available. Okay, so in other words, in terms of scheduling, yes, there is a possibility that you can pass this exam before it changes, which again, that change is February 23rd of 2020. Okay, so how do we prepare for today? How do we prepare for the certification today? And one thing that we've done with some new formatting we're doing on the back end now, we have the current version, what we call the curated playlist that you'll see today. In about a month or so, these are going to be changing over to learning paths, but the logic is going to be very similar to them. Okay, basically what this is, it's all of the technologies, all the classes that we've run for CCIE routing and switching, and we put them in an order where you can basically go top down or skip around if that's what you choose. But the key is that it allows you to have some visibility of what you have done and what you have not done. Okay, so in terms of what order would you want to watch the videos, if you haven't passed the written yet, then obviously start at the ones talking about the written exam. If you have started your lab preparation, start at the lab exam technologies, and I'll show you what that means in just one specific minute. Okay, so let's go to INE.com and to the All Access Pass. Okay, like I said, the formatting of this is going to change, so it makes it a little bit easier to navigate. But if you take a look at on the right, there's this curated playlist link, and I have a feeling that a lot of people didn't even know that this is there because it's kind of hidden over here on the side. But if we go to curated playlists, you'll see they're listed based on the certifications. So CCNA routing and switching, CCIE routing and switching, this is the one that we're going towards. Now, if you notice the hour count, the one by far that is the biggest track is going to be routing and switching. It's got 500 hours and 69 courses. Now, you don't necessarily have to go through all of this, but the point of this is that the curated playlist is going to give you kind of a top-down view as to what you may want to take a look at. Okay, first and foremost, we talk about how are you going to do the examples that we're using in the exam or using in the videos. So if you don't already have a virtual topology, I would look at using Viral for this. Another option, of course, is GNS3 or Eve NG. But the point being is that you need to make sure that for every video you're watching, you're also practicing the labs that go along with those. So in today's session, I'm not going to map those on a one-to-one basis. The volume 1 labs, the volume 2 labs, those will map to the curated playlist. But basically, you should be able to see this when you look at side by side what labs that you're expected to do. Okay, next we have the written exam technologies, which the first one is going to be the main course, 32 hours. Okay, I believe this one is by me. Yes. Okay, so this goes through the blueprint, and then a lot of this stuff from a theory point of view, but not necessarily from an implementation point of view. But again, it depends on where you are in your current preparation. Hopefully, most of you have already gone through the written exam. Otherwise, you need to get that done very soon because it doesn't happen overnight that they give you access to go onto the lab exam scheduler. Okay, so the first main one that I want to look at here is the lab exam technologies. Okay, previously this was called the advanced technologies class. You can find it in either format. It's just linked top down a little bit better here. So what I would like to do next is to go through the specific blueprint, and then we're going to map it to these videos. Okay, also another feature of the curated playlist is that there's multiple authors, which gives you multiple perspectives. And in my personal opinion, I like this approach, where when I was studying, all these technologies back in the day, I would read multiple books on the same point of view. I would read multiple different documents at the same point of view. There wasn't video training at that time, but I would recommend to do the same thing, that there might be one thing that you pick up from one instructor, another thing that you pick up from another instructor, and the key for learning is always repetition. So it cannot hurt to watch these same technologies over and over and over from different instructors. Okay, so what I would recommend to do is to use here the lab exam technologies, and then the other stuff beyond that, you can use this as kind of a peripheral review. Okay, so now let's talk about mapping the blueprint. So let's go to the current CCIE Routing and Switching V5 blueprint, which is, let's see if this link works today. Yes, it does. Okay, for our exam topics, and it says our last date to test is February 23rd, 2020. Okay, if you want to learn more, that's going to talk about the new exam changes. Okay, we want to download the complete list of topics in a PDF. Okay, CCIE Routing and Switching, Lab Exam version 5. It says Lab Exam version 5 is an 8-hour hands-on exam which requires you to configure and troubleshoot a series of complex networks to a given specification. Knowledge of troubleshooting is important, and candidates are expected to diagnose and solve issues as part of the CCIE lab. You will not configure any end-user systems, but are responsible for all devices residing in the network. So again, what this means is that in this current format, troubleshooting is a separate section. Okay, so there's a lot of videos on troubleshooting, whatever, troubleshooting OSPF, troubleshooting BGP, troubleshooting Ethernet switching. Make sure that you take a look at those so you know from a high-level overview, how could I identify this problem, okay, that it is an issue, and then what are the different show commands, what are the different fixes that I can do in order to resolve this. Okay, next it says the following topics are a general guideline for the content likely to be included on the exam. However, other related topics may also appear on any specific delivery. In order to better reflect the content of the exam, the guide below may change at any time without notice. Okay, so what I would like to do is to show the actual blueprint side by side with the curated playlists, which is going to be this guy here. Okay, so under curated playlists, we have CCIE Routing and Switching. And then under Lab Exam Technologies, our first one is LAN switching. Okay, first off, LAN switching starts with just an intro, VLANs, VTP, and let's go ahead and mark these off on each of these. Okay, VTP is covered. Okay, which also includes .1Q, so VLANs are included in there. VTP version 3, VLAN trunking protocol, VLAN access ports, layer 2 ether channel, layer 3 ether channel. Okay, so that's going to be implement, troubleshoot ether channel. Okay, ether channel load balancing will be in there. Okay, so basically we'll just say 11E. So 11D we got. Implement and troubleshoot VLANs, yes. Implement and troubleshoot layer 2 protocols, CDP, LLDP, UDLD. This would be throughout the series to say, let's look at show CDP neighbors, make sure they're connected. Okay, nothing really too complicated about that. Then there should be here something under spanning tree. So PVST, rapid PVST, multiple spanning tree, all of those are going to be covered in this particular section. Okay, so let's say that you get to the end of layer 2 technologies and you still want more information on this. You could go down to additional resources. You can see that there's a section that is on, or actually maybe that was it at the top. There is a section under written exam, 802.1D spanning tree and PVST. Okay, rapid spanning tree and multiple spanning tree. So if you're not 100% sure about what I had said in my particular course, then you can continue to move on to the other ones. Okay, but overall, everything in layer 2 technologies is going to be listed there. Okay, layer 2 multicast we'll come back to. We'll look at layer 2 and layer 3 multicast at the same time. Okay, then we have layer 2 WAN circuits, which is basically going to be just PPE, or PPPoE, excuse me, dropped a P there, which is going to be under layer 2 LAN circuits. Okay, layer 2 LAN circuits is WAN circuits, PPP over Ethernet. Okay, there we go. Okay, so not a ton that's really involved with that. Okay, troubleshooting layer 2 technologies. So for any of you guys who have watched any of my videos, you know that troubleshooting is already included in there, and that we spend a ton of time going over the packet capture. So we could just cross this one off. Yeah, we did troubleshooting for layer 2. Okay, next we have layer 3 technologies. So identify, implement, and troubleshoot IPv4 addressing and subnetting. Okay, in my courses, I don't really go over subnetting, but there should be some other peripheral ones up here that talk about, here's one that's on just IP routing. And in the scope of the routing and switching lab exam, you're not doing a lot of subnetting. You're not like building the addressing architecture for it. So you don't need like a calculator or anything like that to solve the questions. Okay, so this one we'll check off because we do talk about different types of addressing throughout the series. Okay, then the same is going to be true for IPv6. In the case of IPv6, this should already be listed in there as IPv6 routing. And then under IPv6 routing, IPv6 addressing overview, that's going to be covering this stuff here in 2.1 beta. Okay, layer 3 multicast we're going to skip for now. We'll come back to that after we talk about fundamental routing concepts. Okay, fundamental routing concepts are very important because this is where we talk about redistribution. This is where we talk about filtering, about policy routing, minor features like bidirectional forwarding detection. So this is not going to be cleanly grouped into one section, but under route redistribution, there's a whole section just on route redistribution. Okay, then likewise, IPv4 protocol independent routing. This is going to be things just like IP static routing, policy routing, using the service level agreement. Okay, and this is what we're effectively talking about here. We have static routes, we have default routes. We're troubleshooting and optimizing administrative distance and troubleshooting filtering or redistribution between any protocol. That's going to be the combination of this section, IPv4 protocol independent routing, and then also route redistribution. Okay, so route redistribution has a number of good case studies that you should go through, test these out, and make sure that you can get them to work functionally. And then last one was convergence optimization. Okay, convergence optimization talks about bidirectional forwarding detection. Okay, how do the events get propagated to the other routers? What happens when they see that there's a failure in the topology? That stuff is going to be listed here under section 2.3, which is just fundamental routing concepts. Okay, some of the stuff is going to be miscellaneous, like implementing and troubleshooting routing protocol authentication. We would be doing this for every single protocol. So that's why it's listed under just routing protocol independent configuration. Okay, next, RIP version 2, very simple, implement and troubleshoot RIP version 2. So hopefully we have RIP version 2, which we do. Okay, we have about 3 hours on it. So more than you would hopefully need. So just overview of the protocol, how do we do authentication, summarization, default routing, what are some of the additional commands, features that they could ask you to do in RIP, and then also for our filtering. So as I mentioned here, like the authentication, this may not be listed on every single, it may not be listed in that that one section we were looking at before under fundamental routing concepts. Instead, it's going to be under the individual protocols. Okay, so RIP version 2, implement and troubleshoot RIP version 2. We got that one. Okay, next we have EdgeRP, We want to describe the packet types, implement and troubleshoot neighbor relationships. Okay, so we should have more on EdgeRP. Yeah, so about 8 hours on EdgeRP. And in here, what we're mainly looking at is the difference between the named mode and the classic mode. Now, I'm 100% sure if it listed here on the blueprint. Yes, classic metric versus wide metric. Okay, so this one here means named versus autonomous system mode, which is what we're doing here. Named mode, classic metric calculation, the wide metrics, and then how we do named mode. Okay, stub routing, route filtering, that's going to count there. Stuck in active, that's under stub. Load balancing is traffic engineering and unequal cost load balancing. Okay, implement loop-free selection. Okay, that's going to be just the classic metric calculation. Types of multi-addresses for named mode. So I believe later in IPv6, that's where we cover all of the protocols together. And then lastly, implement, troubleshoot, and optimize EdgeRP convergence. IPFRR fast reroute. So where this was, this section here is under convergence optimization. Okay, so you can come back to that once you go through redistribution, BGP, convergence optimization, because the key here is that this applies to all of these protocols above, applies to BGP, to OSPF, to EdgeRP, and to RIP version 2. Okay, for OSPF, this is probably where you're going to find the second to most content as second best to BGP. So we have 13 hours. Actually, they're pretty close to each other. Okay, so OSPF, we have 13 hours on OSPF. And it says we want to know the LSA types and we want to know the route types. Okay, those would be listed under the not so stubby areas. Configuring OSPF stub areas. Traffic engineering with stub areas. NSSA redistribution. So these can definitely get involved. You want to make sure that you start at the top and then work down because it kind of builds along in order to create these. Okay, implement and troubleshoot neighbor relationships. This would be troubleshooting OSPF adjacencies. Okay, so most of this we got. OSPF v3 we'll come back to. Implement and troubleshoot network types and area types and router types. Okay, so this would be OSPF areas and LSAs. Media dependencies and network types. Point to point, what can it be adjacent with? Can it be adjacent with broadcast or point to multi-point? You tell me. Okay, then we have, okay, so our types. Okay, stub, NSSA, total stub, etc. Implement and troubleshoot path preference. This would be OSPF path selection. Okay, implement and troubleshoot operation, generic operations, graceful shutdown, generic TTL security mechanism. Now, this one here, I believe that there is no code support is what the issue is, at least when I was recording these particular videos. So if you find any line item that's not listed on the videos, just Google Cisco's website for it. It could be a very basic option, that it could be just 1 or 2 commands that you need to add for that. But basically what this means is that you have 2 routers, router 1 connected to router 2, and when you send a hello, we're trying to prevent some sort of man in the middle attack, and the way that we can do that is by setting the TTL to 255. So if you set it to 255 and it comes in with the maximum TTL, router 1 is already going to know that that router 2 is directly connected. So in other words, it's trying to prevent the hello from coming multiple hops away, which would be some sort of exploit inside of OSPF. Okay, implement, troubleshoot, optimize OSPF convergence and scalability. So that's going to be in that separate section that is for convergence optimization. Okay, metrics, SPF tuning, fast reroute, LFA, that's all going to be inside, likewise, that convergence optimization. Okay, next we have BGP. It says describe, implement, and troubleshoot peer relationships. Okay, so establishing peers. We have the overall rules, eBGP versus iBGP, doing a full mesh, doing scaling with reflectors and confederation. I want to say that basic BGP operations is going to be the one that talks about the neighbors, the states and the timers. That's just establishing basic BGP. Okay, implement and troubleshoot iBGP and eBGP. Okay, that would be the peering rules. Explain the attributes in the best path selection. Okay, that's down here, BGP best path selection. Troubleshoot routing policies, attribute manipulation, conditional advertisement, outbound route filtering, communities. This is going to be traffic engineering with communities. BGP filtering, BGP best path selection. Okay, so there's going to be a lot of modifications here in terms of what we're trying to optimize. Okay, implement and troubleshoot scalability, route reflectors, confederations, and aggregation. So we have route reflectors, confederation, traffic engineering with aggregation. Implement and troubleshoot multi-protocol BGP. Okay, VPN address family, that's going to be for an MPLS layer 3 VPN, which we have in a separate section of the videos. Okay, troubleshoot ASPath manipulations. That's going to be part of MPLS as well. Multipath synchronization, software reconfiguration. Those should be touched on a little bit, but they are fairly minor features. Multipath is touched on in MPLS layer 3 VPNs in terms of how to load balance within the service provider core. Okay, next we have troubleshooting layer 3 technologies. This is pretty generic, just saying we're going to be using Wireshark, okay, which in a lot of these videos I am using Wireshark. You can't use that in the exam, but they may give you, like in the diagnostics section, they may give you a screenshot of the packet capture, then they ask you questions on it, but you won't have access to a live capture. Okay, next we have VPN tunneling. This is going to be our MPLS layer 3 VPN. So if we go back to the main page, or the main curated playlist, this is going to be under MPLS. Okay, so under VPN technologies, this is going to map to the label stack, okay, LDP, label distribution protocol, which is under MPLS. Okay, label distribution protocol. Implement and troubleshoot basic MPLS layer 3 VPNs. So this would be L3 VPN overview, configuration, verification, and then troubleshooting. Implement, troubleshoot encapsulation. So there's many cases where we use GRB tunnels throughout the series. So we can kind of set that to the side. What this is talking about here, 3.1D, implement and troubleshoot DMVPN, this is going to be a different section. So basically all of this here is going to correlate to implement and troubleshoot basic MPLS layer 3 VPN. So with either RIP, with EHRP, OSPF, BGP, you need to be prepared to use any of the routing protocols as the PE to CE routing. Okay, the other section is going to be under DMVPN. So these are essentially both WAN transports. So under DMVPN, we have details about NHRP, which is going to be under phase 1, 2, and 3, talking about the difference between how NHRP works. DMVPN with IPsec using pre-shared keys. So in there, we talk about some of the basics of crypto, not to the level that you would use for CCIE security. But at least to get the basic tunnel up and working. Okay, same here. This is going to be how do we apply a QoS profile onto the GRE tunnel. The key point here is, do we do the encryption first, or do we do the tunnel encapsulation first? There is a difference between the two of these, and this is covered in this particular class. Okay, encryption, IPsec with pre-shared keys. This is going to be the same thing basically as DMVPN. The difference is that it's not going to be a multi-point tunnel where DMVPN we would have spoke 1, spoke 2, and then the hub. They would be forming IPsec tunnels to the hub, and then potentially forming an on-demand tunnel to each other. Okay, next we have troubleshooting VPN technology, so that's pretty much the same thing. So in the DMVPN section, there's definitely a bunch of troubleshooting that's listed in there. Okay, next section is infrastructure security. Implement and troubleshoot iOS AAA using the local database. Implement and troubleshoot device access control. So this is kind of just generic iOS troubleshooting, that when you're practicing for this stuff, you don't really need more than one node. So if you're running like GNS3, this is the perfect thing when you're bored, you have 10 minutes, work on one of these topics. And this is going to be covered under network services, either iOS security or network services. Okay, so iOS security is control plane, policing and protection, which is, I'm not 100% sure if it's listed on here, but it would be, actually, let me search for it. It would be COPP or COP. Now, it is part of it, though, here under infrastructure security. So we have control plane policing, which is going to be the underlying COP policy. Then, there we go, implement and troubleshoot control plane policing, COPP. Okay, so that's our first one. Then we want to do access security. Okay, access security would be the management plane protection. Okay, like how do you log into the router? Network security. So we have Catalyst port-based traffic control. That would be things like IP source guard, dynamic ARP inspection, port security. Okay, private VLANs is listed in there. DHCP snooping, ARP inspection, IP source guard. Yeah, so basically all of these go along with this section here in iOS security. Even though they're technically switch security, not that big of a deal between the two of them. Okay, the other one we had was network services. Okay, so network services is going to be first hop redundancy, and then also NAT, which is what? Let's search for NAT. Static NAT. This is under network services. Okay, so network services, first hop redundancy protocols. That's HSRP, GLBP, VRRP. Network address translation, which is going to be this.
and then DNS and DHCP. Okay, the one that we did skip, I think, is IPv6 routing. So in IPv6, we have the protocols separate. Okay, so addressing overview, this would talk about stateless auto configuration inside IPv6. Then when it talks about in the other protocols, like OSPF v3, OSPF v3 is separate in IPv6 routing. Okay, so let's see, what did that leave us that we don't have? Okay, section 1.1 for layer 2, that's good to go. Section 1.2 and 1.3, so we didn't talk about multicast yet. Okay, multicast should be here as its own section, which it is. Okay, in multicast, we have layer 2 multicast at the end, because you need to understand how PIM sparse mode works before you can get to that. Okay, so layer 2 multicast is listed, and then if we search for multicast, layer 3 multicast. Okay, troubleshooting multicast RPF failures right there. Okay, next is what? Implement and troubleshoot IPv4 protocol independent multicast, PIM dense, sparse, and sparse dense. Okay, that's the first. Static RP, auto RP, bootstrap router, correct. Bidirectional PIM, source specific multicast. Group to RP mappings, that happens inside the these videos. And then multicast boundary would be doing just a type of filter. Implement and troubleshoot multicast source discovery protocol intra-domain. This would be for Anycast RP and for MSDP, which is also covered there. Okay, let's see if there's anything that we're missing out on. QoS. We talked about everything else. QoS. And remember that these platforms are virtual, so there's certain features like in QoS that won't be supported. Okay, implement and troubleshoot end-to-end QoS. So that is going to be classification and marking comes first. Okay, classification and marking the traffic. Okay, then what do? We could police the traffic, or we could shape the traffic, policing and shaping. We could use some sort of management technique. Congestion management would be queuing. Okay, congestion avoidance would be random, weighted random early detection. And then hierarchical QoS for subrate Ethernet links. This would be right number here, here, the second one on the list. Okay, so let's see if there's anything that we're missing from the high-level blueprint. Now, there might be minor items, of course, here, but you guys do need to do some research on your own. But the point being is that the vast majority of this is going to be covered in that section, which it is. Okay, the other thing that you can do here is take a look at our INE CCIE Routing and Switching v5 expanded blueprint. What this is going to help you do is to have a checklist that's a little bit more detailed than the actual exam blueprint. Print this out and then check it off as you're going through your topics. So it's pretty much the same thing as we saw before, just the topics are expanded further. And then literally, like I said, just print this out, use this as a checklist as you're going through the videos, because this checklist is going to be more detailed than the one in the Cisco's official blueprint. Okay, and last but not least, the curated playlists. So again, the way that you get to the curated playlist, because it is not 100% obvious, is if you go to streaming.ine.com, then to the left of the search bar, click this little map for curated playlists. And then the one we're looking for here is CCIE Routing and Switching. So only 500 hours that you guys need to go through, right? 500 hours before Feb 2020. It should be a very simple assignment, right, guys? Okay, so let's go ahead and open up the Q&A. Okay, first and foremost, I see one there. Is RTP no longer a testing site? Yes, that is true. Only Richardson, Texas is a testing site. San Jose and Raleigh were closed.
Okay. Here is another one. It says, I plan on taking the written exam before the change, however, not the lab exam. What are you, INE, doing to prepare students for the new blueprint?
Okay, so the question is, you're going to take the current written exam, but the new lab exam. So within the next month or two, we're going to start to release the new modules for the CCIE Enterprise Infrastructure. The issue first is going through the details of the software-defined access, the software-defined WAN, and figuring out what physical equipment is needed for that. So if any of you guys are into SDA or SD-WAN and know how the virtualization works, shoot me an email. I would appreciate that if we could have a brief conversation about what has and what hasn't worked. The other potential option for this is to use Cisco dCloud, which is dcloud.cisco.com. But I don't yet know if the DNA Center is what the issue is. The Cisco DNA Center, I believe it's currently a UCS appliance that you have to buy, as opposed to just a virtual machine that you can use. But we do have a plan for releasing that new content.
Perfect. Here is another one. If you are already a CCIE and R&S, will it automatically become an enterprise infrastructure certification?
Now that one's kind of interesting. The question is, if you're already R&S and you just wait and you do nothing, I believe what the program meant that yes, you will change to CCIE Enterprise Infrastructure. I'm not really 100% sure why they're doing it that way, because they have renamed tracks in the past, like they renamed voice to collaboration, but they still took both of them, or they still left both of them separately. But either way, you still maintain your status as long as you have an active written exam.
Okay, here's another one. I scheduled for the farthest out date that was available for October 7th. Am I required to take it again 30 days later? I may need to study more than 30 days to catch up on the things I've missed.
Okay, so you're scheduling for October. Do you mean for the written exam or for the lab exam? If you're talking about the written exam, the potential problem is that you won't get access to the lab scheduler until September. No, if you're taking in October, you won't get access until November. And then in that case, you only have 2 months to book dates. Typically what happens when they change formats, they have to close the exam a bunch for instructor training or proctor training. So I personally would not wait that long. I would try to push it up to July or August at the latest, if you really want to take the current format. If you want to just take the new format, I mean, there's nothing wrong with that. We're going to have to learn these new technologies going forward anyways. It just depends on, do you guys want to do it now, or do you want to do it a couple years from now?
Okay, and here is another one. Are there any plans for rack rentals / labs being available for SD, WAN, and DNAC labs? Currently, DNAC is only a super expensive appliance, so labbing is difficult.
Yeah, so that's the issue I was talking about. The DNA Center is a appliance, and let me see if I can figure out the let's see, DNA Center. Okay, let me see on the data sheet if I can find the part number. Part number, which is this guy. Yeah, that's good. That's going to be the issue, guys. $88,000 for the DNA Center appliance. So if anybody has 90 grand sitting around that would like to donate to our equipment, let me know. But otherwise, there is word on the street that this will be virtualized. I don't 100% know when. So I believe the idea is that we're going to be starting with the SD-WAN, because the SD-WAN stuff is virtualized as far as I know. But otherwise, probably not. We probably won't be hosting this equipment just due to the expense, like you said.
Okay, it looks like we have time for one more question I'm pulling right now. Is it preferable to give new CCIE Enterprise Architecture, as it will allow us to gain knowledge at automation and latest technologies?
So the question is, would you rather do the old format or the new format? I personally would say the new format, because it's going to push you to learn that new stuff, which down the road, it's going to help you out anyways, because everybody's doing automation nowadays. Everyone's doing programmability. That's effectively what DNA Center is, what SD-WAN is. The idea is that really the network is getting too complicated to manage it from the CLI. We need some sort of central resource where we see the switches as nodes or just the routers as nodes, and then we're logging in from some central resource in order to make those changes. That's effectively what DNA Center is. So DNA Center is like the APIC controller for their enterprise, for Cisco's enterprise solution, which is the Catalyst 9Ks down to the edge, where APIC is the Nexus 9Ks for the data center. So definitely, yes, it's gonna add to your skill set by learning either DNA Center or SD-WAN. Thanks, guys. I hope to see you back for further sessions at INE. Have a great day.